Good evening, everyone. A warm welcome to all the participants joining us today for the much anticipated webinar, Unlocking the Secrets of Winter Solstice. I am Rishita Sharma, your host for today's session. As an educator with a passion for astronomy and science outreach, it is my privilege to guide you through the exciting event. We are gathered here on a special occasion that is winter solstice, a day of astronomical significance when the sun reaches its lowest position in the sky, marking the shortest day and the longest night of the year. At the heart of today's event lies our mission to understand, observe, and appreciate the universe's wonders while learning from experts who have dedicated their lives to advancing science and space exploration. This event is brought to you by Space India. Space India has been a leading educational force for over 2 decades, popularizing astronomy, space science, and STEM education across various academic levels. Collaborating with over 100,000 schools and inspiring more than 1.5 million students, Space India is revolutionizing space science education with innovative curriculums, workshops, and experiential learning activities. It is committed to making a scientific impact closely aligned with a UN Sustainable Development Goals. As an officially recognized space tutor and merchandise partner of ISRO, our mission is to nurture curiosity and knowledge about space exploration and astronomy across all sectors, including education, hospitality, and tourism. Since its inception in 2001, Space India has launched impactful programs like the All India Asteroid Search Campaign AIASC with NASA and Astronaut Sky Tourism in collaboration with the Ministry of Culture and National Science Centre, Delhi. So without further ado, our first esteemed speaker for today's event is Dr. Arun Bhardwaj, a senior scientist, engineer, SG at ISRO's Delhi office with over 27 years of experience. Dr. Bhardwaj has played a key role in iconic missions like INSAT, Cartosat, Chandrayaan-1, and Mangalyaan. A physicist by training with a PhD in theoretical superconductivity, he has contributed significantly to developing advanced space systems and leading strategic initiatives. He has also been a part of pivotal national projects, including Urban Flood Forecasting and Mega Science Vision 2035, and is a member of esteemed organizations like the Indian Society of Remote Sensing. His work contributes to inspire the next generation of space enthusiasts. So, ladies and gentlemen, please join me in extending a warm welcome to Dr. Arun Bhardwaj. So the stage is yours. We are eagerly awaits your insight and words of inspiration.
Thank you, Rishita ji. Thank you, Vikrant ji. Firstly, let me thank Space India. And it's a really good initiative that you have brought so many students from across Delhi and NCR region. And today is a very apt day, 21st December, as you mentioned, it is winter solstice. And of course, many of our senior students will be aware, but just to again, I will reiterate, this happens because of our Earth's tilt. Our Earth is tilted with respect to the Sun and Earth plane by 23.5 degrees. And this tilt is very important. Without this tilt, we will not be having the seasons that we face on our Earth. And seasons are very important for the cropping pattern. Similar to this winter solstice in June, there is a summer solstice, meaning the longest day on the northern hemisphere, and there are two equinoxes. Many more interesting aspects on winter solstice will be shared by Vikrantji, so I will not intrude into that. And I would like to share few of my thoughts and what I have learned in ISRO and how the history of ISRO is. So basically, ISRO is more than 60 years old, and at that time, I'm talking about 1963. It was a very, a time when there were two blocks, political blocks in the world. If you have read the history, there was a American bloc and there was a Russian USSR bloc. India was in a very nascent developing stage. Only 16 years after independence in 1963, we thought of starting a space program. And all this credit goes to our first chairman of ISRO, Dr. Vikram Sarabhai. So the people who had started this, we are just reaping the benefits of those days. At that time there was a lot of voices in terms of political and even other academic circles, that why a poor country like India should embark on a space journey. Because I would also like to add that that was a time when we used to have a lot of wheat shortage, and unfortunately we were dependent on aid from USA. They used to send ships of wheat under a program called PL480. You can search on the Google. But luckily, the Prime Minister of that time, Pandit Jawaharlal Nehru, and our scientific community, they came together. And the advantage of that endeavor, I will like to tell you how it came to help us in mid 70s. So, all my friends, I would like to say that any scientific new anything which we start today, we may not get immediate result within a year, 5 years, but it has a long term implication decades later. The immediate implication which I would like to share to you was that because of our space program and official space program in the mid 70s, when the geostationary satellite orbits were being defined for each country, in that negotiating table, India was also invited because India has a space program. Although we had not yet launched a full fledged communication satellite by that time, but still, because of our space program, we were invited on that table and we got exclusive three slots, one above 72-degree east, 84, and 93 degrees. And that is not a simple thing. Had we not there, all these three slots would have been taken by many of the Western countries or maybe America. So the space program started, gave us immediate benefit at that time. Similarly, there are many other programs. If you start sometime like Antarctica expedition, many would say that there is just a snow, but you don't know what would be discovered in later years, another 50 years. Suppose we are not there, naturally we cannot claim to have any of the mineral resources or any other thing which will be discovered in the future. Same is the case with the moon. As you know, we landed on the moon on 23rd August 2023 through our Chandrayaan 3 mission. In future, suppose there is a situation arises that okay, the moon is divided. We may say that today that okay, it's open to all the countries, but political situation, what happens in another 50 years, we do not know. Because we landed there, we have the capability to land there. So whichever countries like USA, Russia, China, Japan, and India, they will be there to decide the future of the moon. Those who could not reach moon, they cannot claim that we should also be on that negotiating table. So apart from this, most of the time, as we have seen on the TV screen, a rocket launching from our launching pad, Sriharikota, and of course, it becomes a moment of pride for all of us, all our citizens. But apart from that, satellite system, our space technology has given us immense, many spin-offs. We are in Delhi. We do not have any sea coast nearby, but I'm sure that many of you must have stayed on the coastal sides also. Particularly, maybe some of you has visited Andhra coast, Odisha coast. In the Bay of Bengal, regular cyclones comes at a very regular interval. And 22 decades back, they used to cause a lot of devastation, not only the material but the loss of life. Once we had our meteorological geostationary satellites in place in the 36,000 above the surface of the earth, whenever a cyclone started in the southward side of Bay of Bengal, we were able to monitor it, its complete movements, its speed, and where it will land. By landing, I mean where it will hit the coast of Andhra or Odisha. This gave us ample time, 5 to 7 days, that we are able to warn the district administration, and district administration used to take a lot of actions by evacuating all the residents living in the villages to the safer place. And it's a really happy moment for us that in last many of the cyclones there has been minimal or absolutely no loss of life, because we cannot stop the cyclone. Our aim is that our citizens are safe. So these are one of the spin-offs. And I would also, as our host wanted to tell about me also, so I would just add a few things. I joined in 1997 in the one of the very big centers of ISRO in Ahmedabad, that is called the Space Application Center. And that center builds all our imaging cameras, I mean the way you see the Google pictures. Our cameras are no less, in many respects they are superior to the images that you see on Google. So we had our imaging camera starting from Cartosat 1, Resource Set 1. They give us very high resolution pictures. Apart from that, we had meteorological satellites, communication satellites. They are stationary above the equator and directly facing the India. The other satellites in the low Earth orbit, 500, 600 kilometers, they keep on moving around the Earth, sometimes 90 minutes per round or 98 minutes. So that is how the our ISRO journey has been. We started with simply making satellites, then we moved to the launch vehicles. Now we are completely, we make our own satellite, we launch our own satellites. Our Chandrayaan 3, it went on our own rocket launching system. Similarly, we had many further plans, Chandrayaan 4, Chandrayaan 5. So after spending 19 years at ISRO Ahmedabad, I came to Delhi in office, which is called the scientific principal scientific advisor to the Government of India office, which works on the policy advisory role in science. So there also I spent more than 7 years, and I'm again back to ISRO. So I would my this is my own view based upon my own life experience, that it's good that many of our science students are trying for medical and engineering, but there is always an ample scope for the students who take up basic sciences. Basic sciences, I mean physics, chemistry is there, even mathematics also play a lot of role, because it has happened in my own life. If I'm given few minutes by Rishtaji, so I can add few more points about my own journey. So it happened, I was finishing MSc Physics, and in 1994, I got selected through Union Public Service Commission as Assistant Provident Fund Commissioner. And before my MSc results were out, I joined in Bombay, now Mumbai. After 1 month, so I thought I would take at least the salary of 1 month. Why should I leave that? So immediately on the day of salary, I took my 1 month salary, and next day I came back to Delhi, and I joined the research PhD at University of Delhi. Those are very wonderful years. And after that PhD, I joined ISRO. So my own experience says that nothing to despair. Try to do whatever you like, you have a passion, and it's not that pure sciences will ever fade away. Pure sciences are the basics of whatever technology development you see. Even our ISRO, we have all the technologists, scientists whose field are physics, chemistry, agriculture, oceanography, marine scientists, those who study glaciers, those who study snow, forest. So it's never like that you have only these two chosen fields. Of course, they are important. Every field is important. I'm not saying that we should completely neglect that. But the experience in ISRO has taught me that we can pursue whatever passions. And the another reason for the ISRO reaching such great height is the leadership. Personally and overall, all my ISRO scientists, and I'm also speaking on the behalf of many other departments, scientific departments, we have been lucky to have the greatest leadership of our time. Dr. Vikram Sarabhai, who started the ISRO, was a great man. I'm not, he's apart from the scientific, he was one of the greatest scientists of his time. The centers of ISRO in Ahmedabad, Indian Institute of Management in Ahmedabad, Physical Research Laboratory in Ahmedabad, all were set up by Dr. Vikram Sarabhai, and many times donating the land on which they were formed. So this I am telling you because this is too distant in past for the present generation to think about what happened in 60s and 70s. But remember one thing, whatever we are seeing today is not just happened over a months or years. It took more than 5 to 6 decades to happen. Now we're in a very strong position, and our future young generation, all those who are now joined today, they should take it forward. You have the energy, you have the technology, you have the support, and also economically we are in a very good position. And now the private sector has also entered in this space field, just like in USA. So all you young people have a lot of things which you can say, which we are only theoretically thinking of, reaching the Mars, to the moon, which may happen very much in your lifetime and at a much reduced cost, which will make the space exploration just like a space tourism. If Rishita ji permits me, shall I take a pause here and hand it over to the Rishita ji?
Yes, sir. Am I audible, sir?
Yeah, clearly.
All right, sir.
I will again come back once the Kanji also gives his take on the
Sure,
topic.
sir. Sure, sir. Oh, all right. Okay, thank you so much, Dr. Bhardwaj, for the fascinating session. I'm sure our audience is inspired as I am. We all actually really glad to hear your inspirational story, how you got into ISRO, how you actually preferred your passion over a government job, actually. So now we are moving on to the next segment. So before we move on, we invite the students to submit their questions through the provided Google form for our interactive session, which is pinned in the comment section. Moving on to the next segment, our next esteemed speaker for today's event is Mr. Vikrant Narang, the Chief Technology Officer of Space India. Mr. Narang holds an MSc in Space Science and Management from France and has been instrumental in establishing an innovative astronomical observatory in the NCR region. As a passionate educator and astronomer himself, he is dedicated to inspiring future generations in the field of astronomy. Ladies and gentlemen, without further ado, let's delve into the fascinating journey of one of the India's greatest contributors to astronomy. Over to you, Mr. Narang.
Yeah,
Sir,
thank you so much for giving me the opportunity and welcome all of the space students and everyone who is joining us. I can see people, 211 people are already there, and we have wonderful questions received from all of them. And I would like to thank Dr. Arun Bhardwaj for the wonderful speech he has given us, and the insights into ISRO and his own journey. We will have a question and answer at the end also, but right now I would like to talk about happy solstice to everyone. Today we are celebrating the winter solstice. That is the longest. So what is happening right now is that the longest night is there tonight. And after this, so basically it is the start of the winter. Today it happened at 2:51 p.m. So although we are celebrating the winter solstice as a day, but it actually is a moment in time. So there's a very special moment in time when the earth crossed a particular point, and after that, so it's this day is also called in astronomical, like astronomically, this day is also called as the start of the winters. I'm sure you all enjoy seasons. It's called start of the winters, and you must be wondering, okay, so if it's start of the winters, then it should get colder. Yes, it will get colder, no doubt, but the nights are going to get shorter. So we will understand why this happens. What is winter solstice? So I would like to tell you a little bit about myself and my organization, Space India. So many of you are already part of it, having part of our different programs. Let me put it on slideshow mode. So I hope my slideshow is visible. So Space India is running since 2001, and we have catered to more than 1 million members, 1 million students across the globe, and we are reaching out to more than 100 schools every year since 2001. So we have reached almost across the entire span. We have reached to about 2,000 schools till now. Astronomy is the most interesting science, and unfortunately, it was missing from the school education system. So Space India's founder, Dr. Sachin Bamba, wanted to have astronomy as part of the school curriculum. You know that we teach hands-on astronomy education, as you can see. Okay, so here in this picture you can see we went to Jantar Mantar. We are conducting a public outreach program, so we create a lot of awareness so that we can create scientific temper. Why do we study astronomy? Because for happiness. So basically astronomy leads us to understanding our world. There are so many mysteries, and in the past, as we will understand, in the past, astronomy is one of the sciences which was most critical for the survival of humankind. Even if you look at today a watch, in a way, when you look at a watch which has a minute hand and an hour hand, so hour hand takes one round in 12 hours, while the minute hand takes 12 rounds. So it is very similar to the moon taking 12 rounds of the earth, while apparently when you look at the sun, it's taking one round in a year. So perhaps this clock, like the circular clock, has also come from this notion of astronomy. So here we are at the Jantar Mantar conducting one event, and here we are. So we believe in hands-on astronomy education. Here we are safely observing the sun. So one caution, like you should never view the sun directly. So we conduct a lot of activities, a lot of observations right there in schools with school students. So I particularly started my journey in astronomy when I was very young. I made my own telescope when I was in class 10th, and I have gone and seen many total solar eclipses with our organization. We have established astroports. We have discovered, like our students have discovered asteroids. So I am very happy. Like I'm most happy when I'm teaching astronomy. So without further ado, I'll start about the winter solstice, what we are celebrating. So New Grange, winter solstice. This is today's photo from New Grange, Ireland. There is a tomb you can see where the people have gathered. This was just 2-3 hours back, and today is winter solstice. So what was happening is there was a celebration going on. It was live webcasted, and this is some photos from the past. This is the tomb. So what is the significance? This was constructed 5,000 years back, and you can see on the right there is a shaft, there is a passage, and there is a sunlight shining. And if you look at this particular, there is a window, and exactly only centered around this particular day, you can see the sunlight would enter this passage and illuminated a chamber inside in the depths of this tomb. So this was a marker for the ancient people to know that the sun is going to go higher and the better days are ahead. So today we were waiting at the webcast, and this was like from the chamber inside that tomb. There is a small opening. You can see there, like the window is ahead of this. So there was some cloud, but we can see the sunlight was a little bit of sunlight was coming here. We could not see the entire thing. So there is a certain alignment which we are seeing here. So I'll explain you what. Let me tell you. So here if you can see my screen, you can see there is a fish eye image. That means like the way a fish would see. We have a special camera. This picture was taken by an astronomer, Tunk Teasel. Now this was taken, many photographs have been combined, and this is the path of the sun. So this is basically the horizon. This is the path of the sun during winters, and this is the path of the sun taken during summer. These are actual photos combined together to help us understand what is happening during a solstice. And this is path of the sun during equinoxes, and so basically equinoxes. So what we can see is what can you see? See, the path is very little here in winters, and here it is very long. So this is in summers, sun is taking a very long path, while in winters, sun is taking a very short path. So basically, all of you enjoy seasons. One of the reasons is this. So you are enjoying gajar ka halwa these days. You must be enjoying lemonade in summers. So seasons give us, so you must be in your sweaters right now, and you would like to sleep a little longer. But one thing about winters, we don't like that you get less playtime because the sun sets early and there is more darkness. So imagine now going back to thousands of years when there was no electricity invented. So people could not go out because this was very dangerous. So although they did celebrations where they would light up bonfires, dance around them, the nights were getting longer and they had no hope. Imagine they were like hoping that the sun would again start shining back in the sky. So the nights would, like the days would get longer again. They were fearful. They were called the dangerous winters, or they were called the bottom of the years, and it was very dangerous times for them. So they danced. They were very determined to gods that, through their determination, they would get the sun back in the sky. And that's why I had these rituals also. So we might think it is crazy, but they did not know all the science. They did not know that the Earth's axis was tilted, and this is why it was happening. So you can see that, like what you can see. So, and eventually now even we know, but why are these rituals still continuing? Because somewhere these rituals were so strong at that time, even when the scientific knowledge came back, but they did not want to take chances. What if they believed, like, what if these rituals which they were conducting, maybe some slaughters were done, some like whatever rituals they were doing, dancing around fires or celebrating fires. So they did not want to take a chance. So now I'll show you. So that is why, they still continued, and that is the reflection of those things which we are seeing right now. And even India celebrates Makar Sankranti. So you can see one thing which you can see here in this particular picture. This is a picture in which you can see sun year round. So you can see from April, May, June, July, and so on. You can see in November and December, sun is at its extreme. You can see if you take a picture of sunrise or sunset exactly at the sun, like every month of the same location, you would see that the sun is in December, it is rising in extreme westernmost position. And in June, it is rising at its, here it is at the southernmost position, here it is at northernmost position. So you can see there is a change happening. This is what is leading to the change in the times of our sunrise and sunset. And so here is a beautiful picture, which is again showing a figure of 8. I will show you this from my screen. Okay, Rishita, I need to know how much time I have left, please. So I'll just accordingly, I will.
Go ahead. We have plenty of time, and we all are enjoying as well.
Okay, so I'll just show you what is happening, what exactly is winter solstice. So if I were to, you can see my screen right now. There's a stellarium. I'm like entering in a planetarium software, and okay. So what would happen is, okay, let me restart it. So, what is the cause of while it is opening? So what is this cause? So like sir has briefly explained that this tilt of the earth plays a major role. And I'll show you through this, through the slides which I have with me. So you can see if the earth was not tilted, you all know that the poles would be very cold. Look at the picture on the left. That's my friend in Antarctica. So, and look at this picture, earth is not tilted. So what is happening? The sunlight is falling here on the equator, and the sunlight is also falling near the poles. So at the poles, the sunlight is inclined. So you all know that the equator is very hot always, while the poles are very cold. Can you guess which season this is in this snow? But can you guess which season is this? So it is actually summer season. So it is in Antarctica. On the top, my friend is there. This is the bottom. Someone else is there. But look at this in Antarctica, snow in winters. Sorry, in summers also. So it is so cold. So you can know that both the hemispheres, if you look at both the hemispheres, they would receive equal light if there was no tilt of the earth. But let's see what is happening if there is a tilt of the earth. So here we have earth has a tilted axis, and as it goes around the sun, the direction of the tilt remains the same. And this is a beautiful image. This is showing us exactly what our year is. So it is showing us that the sun is falling on the equator, and here it is falling like on one side. This is the winter solstice time. So you can see the sun is shining overhead in the southern hemisphere. Here the sun is shining over the southern hemisphere, northern hemisphere. So we have summers here. So we have winters right now, but in the southern hemisphere, it is summers going on right now. So I'll, in the interest of time, let me show you what is happening here. So if you were to look at the earth from a satellite, so you can see the earth's, as it moves around the sun, its tilt is changing with respect to the sun. So as a result, you can see sometimes here you can see that the Antarctica, okay, let me just go here. So in September, you can see that the earth, here is the daylight line, and these are the poles of the earth. So as these places would go around the earth, the night side, then imagine the circular earth, as the city would go around the earth, So the day side, this is the day side and this is the night side, they would receive equal light. So, and again at the equator, they would have 12 hours day and 12 hours night. But if you look at any other date, let's say this time, let's say June, December. So yeah, so you can see the southern half is more lit by the sunlight. As you can see, Antarctica is in sunlight, while this part is not in sunlight. As a result, if like a so in Antarctica there would be 24 hours day. So and it would have more sunlight. So why do we have heat? Like, what does sun give us? Heat. And not only it is giving us heat for more time, but it is giving us heat like directly overhead when we have summers going on, and in some winters it is less. So you can see, if there was a city here in northern hemisphere in December, this is the part of the daytime, but there is a longer part which would be, if it would spend in the night. That means in the night you would lose a lot of sun's energy to space, and in the day the days would be shorter, so they would not get enough sunlight. So I'll just show you what is the time, like you can see of various cities, how much sunlight are we getting in these cities. So in different places, in Delhi today, the length of the night is 13 hours, while length of the day is 10 hours. But if you look at St. Petersburg, there would be, so in St. Petersburg, the sun rose at 10 a.m. while it will set at 4 p.m. only. So if you were in St. Petersburg, you would get a lot less playtime, and you would not have to go school also, because like there would be so much night time until 10. So 18 hours. So we were in St. Petersburg in summers, and I remember in 9 o'clock, I came out of a hotel and I saw there was daylight. I was shocked. So it is like strange. You must travel the world to understand, like in India only we experience limited, we have a limited experience. So you can see St. Petersburg is here in Russia. It is closer to the North Pole. So like imagine, these people would be so scared if the nights continue to go longer, what will happen? So this is why these cultures were celebrating Winter Solstice Day. And this is the climate chart of South Pole. I think I'll skip it in the interest of time. So what I'll try to do is, like, there's a lot, but I'll show you only like something special, what we did at Space India. So you can see here, we measured the winter solstice. There is a chart here. So my voice there is very low. So you can see there is a chart. This is our terrace, day before yesterday, and we measured it ourselves. So, okay, astronomers are telling us there is winter solstice, but let's see what we can do. So we can take something like a pole. Sun was on the right-hand side, and through this, sunlight was shining. This is a fixed pole, and sunlight was shining on this chart. The dates are written here. This, like, I know that if at 12 noon, the sunlight is at this point, it would indicate and confirm that there is winter solstice. So you can see what is happening. So there was a shadow. Wait, please. Okay. So you can see, sorry, just a minute. Yeah. So you can see, so there was slightly cloudy. So I'll explain this because this is the most important part, I think. So you can see that the very faint shadow, I think it's not very easy to see, but you can see my shadow somewhere. And there was this pillar shadow going here. And so at 12 noon, if I were to measure the shadow's position of that circle, which you saw up there, it would fall somewhere along this 8. Okay. So if it falls here, I would know that it is winter solstice. And that's exactly what was happening. So this is like a chart. It's like a calendar. And depending on the different times of the year, the shadow of that moon falls at 12 noon in New Delhi at different places on this curve. Okay. So let me ask you this question. What do you think if you were to take a look at the sun, but don't look at the sun directly because it'd be dangerous, at exactly same time in your watch? Do you think it would be at the same place, or would it be at a different place? So it would be actually at a different place. So that helps us know what, whether it is happening, equinox is happening, or what date it is. And yesterday we also confirmed with the help of our educator that, you noticed earlier that I told you that the sun is shining over Tropic of Cancer. But how do we confirm it? Again, here we have a photograph yesterday, day before yesterday, taken at Jantar Mantar. You see this circle here?
Vikrant sir, sorry to interrupt you in between. I am actually checking the comments. The students are saying you to speak a little slowly because they are younger, so it might be a little difficult for them.
Okay. Thank you so much. Yes, of course, of course.
Thank you,
So
sir.
yeah, I was in a like of time, but okay, everyone. Okay, like just let me see the. Okay, so okay, I'll slow a little bit slower, so you can see that the sun is basically over Tropic of Cancer, Tropic of Capricorn at this point of time. And in Jantar Mantar instrument, I'll show you here. So there is a instrument, astronomical instrument in Jaipur city. One of our educators, Simran, went there, and you can see she is moving this particular area. Can you see this moving? Now this is like moving here, okay? This shadow. Now you must be wondering why this shadow is so important. It is important so that this instrument was built by Raja Savai Jai Singh Ji of Jaipur, so that we can know when exactly. So it was to correct astronomical tables. I'll explain. So basically this instrument, you can see these two lines, this double line and this shadow. Only on winter solstice day, that means near 21st of December, can we see that this shadow is close to this. Okay. At other points of year, it would be like, let's say if there is March happening. Now in March, where would it be? Let me explain you. So in March, it would be at a different place. Can you see this particular line? On March, this shadow would fall here. So India was very advanced in noticing astronomical phenomena for many, many years. So this is an ancient observatory, and this has a very important role to play. Going further.
I am a spacian, and you know where we are right now? We are at the Jantar Mantar. At Jantar Mantar, astronomy comes in light. So let me introduce you Jai Prakashan. Jai means, of course, our king. Prakash is signified light, and Yanta representing instrument. So you can see the ship.
So in India, so you can see this is happening, and in India there is Mahakumbh Mela. So there is a, like in Finland there is a celebration where they believe like the sun is kidnapped by someone, so they do some celebrations. So basically different cultures like made some stories. Like in Finland, which is very high in latitude, again the sun would nearly disappear. So they created a story that the sun is maybe eaten by someone or is being kidnapped. So it is fun to understand. And in India, there is something very wonderful happening, that there is something called as Makar Sankranti, which is marking as the upward transition of the sun. That means the sun starts to come north. So let me explain you, as you are very young, as Rishita explained me. So you can see my photo right now in the camera. Okay. So what I can see is, now if I tilt the camera, my face goes up. So if I am the sun, you are the earth, and the camera is like the earth, let's say. So if I tilt the camera, my face goes up. If I tilt my camera upwards, my face goes down. So basically what is happening is that Earth's tilt with respect to the sun is changing. As a result, we see this motion of the sun, motion of the earth. So in India, we have Makar Sankranti festival, which is celebrated to mark the winter solstice, but that date will be 14th of January. So it is not exactly 21 of January, because the year is taken, there are 2 years. So so one thing which came as a shock to me when I was preparing for this talk today is, like, there are 2 years. One is called tropical year and one is called a sidereal year. And in India, astrologers follow sidereal years. Okay. And in Western world we are following, the calendar which you are following, which you and I are following, is tropical year. So what you can see is if you look at this particular diagram, this is exactly a tropical year. So what is happening is that jo aaj ka din, December 21, this day will always be winter solstice. That means this year is defined as when the cycle of the season is completed. All 4 seasons are completed exactly once. That is when the year happens. And what I thought, like, the year actually is like the Earth's motion with respect to when Earth completes one orbit around the sun, and it comes back to the same place with respect to the stars. So that is called a sidereal year, which Indian astronomers are using. So now you must be wondering, what is the difference? ये 2 साल है, तो उसमें फर्क क्या है? बस फर्क इतना है कि जो whatever we thought, like sun should be exactly in the same star, the calendar you and I are following, if you come back 15,000 years later, the sun would not be in the same star. But if you follow Indian calendar, the sun would be exactly at the same place. So there are these 2 calendars. The Hindu calendar, Indian calendar, is like 20 minutes longer. Like 1 year in the Hindu calendar is 20 minutes longer. So what is happening is that the place when the winter solstice happens, sorry, they are celebrating this date today, like in 14th of December, India will have its celebration. But the wrong thing about that calendar, or something wrong, like I don't know whether you can call it or not, that it's no longer connected to the actual solstice day, which is today. So I hope you enjoyed it. There was more I could have done, but in the lack of time, and so I would stop here and over to Arun sir, or yeah. So there is, Rishita, if I would get time, I would like to take it, but let's have Q&A, and I could explain more activities to students later.
It's all right, sir. We have 5-10 more minutes if you want.
Okay, then I would like to show you 2 activities.
Sure,
First,
sir. That would be great.
Yeah, I will show you what you can do. So I will go to this particular. Okay, so what you can do is simply do a fun experiment. You can see my screen. If you, let me play this. So you can see there is a corner of the building which is moving, and it stops. So let me show you again. So this is happening. So if you take your watch and every day, or let's say every 15 days, mark one fixed position, like let's say there's a fixed thing, you mark its shadow every 15 days, what you are going to notice is there will emerge an 8-shaped pattern. It's not very difficult to do, but it requires persistence. So what you can also do is you can take a window where the sunlight is coming and put some small paper on it. And when the sunlight comes at a particular time and that paper's shadow is on a wall, you can note that time, mark that spot, and every few days at a regular interval, mark that spot where the paper's shadow is coming. You will notice that it doesn't come at the same part, but every year it comes back to that same point. So that's one way you can discover winter solstice and summer solstice yourself. It will be your own personal calendar and your own personal solstice. So if there are many questions, I hope I'm able to answer. And then I wanted to do this particular activity where I wanted to show you. So why are we having seasons? So make it very clear that why we are having seasons. So we have taken, so what you can see is I have a device which is called a resistance, and I have a meter. So let's go background. So what I'll do is I'll make a sun here. So this is my sun. Okay, yeah, this is my sun. And my friend and colleague Mehul will help me here. You can come here. So this is a meter. So what we have done is I've connected this meter and the cables to a small device. Now let's understand why are we feeling so cold today. And I have this sun. So you can see some number there. And this instrument is called light detecting resistor, sorry, light dependent resistor. So I'll shine this light on this. Okay. Not working. Wait. Okay, I'll just check the connection. Sorry, just a moment. Okay, so it's not working right now. Something has gone wrong. We'll check it again. So, but what was happening is, like when I hold this resistor, we could see when I tilted the torch here. So what we did is, like when we tilted the torch and this resistor, so it received sun, like I hold it like this, surface is like this, and I put torch like this. So we saw that the light resistor is detecting more light, but if I tilted the torch angle, the resistor clearly showed that there is less light it is getting. So what we understand is that in winters we are getting less sunlight. The intensity of sunlight is less for us. That is why it is colder and the nights are longer. So this is why we are having seasons. So if it is ready, I'll show you later. But thank you so much for your time. Rishita, over to you.
Can I make just take 1 minute?
Please, sir, please.
Sure, sir, sure.
Because Vikrantji has given so many interesting things. I had noted 1 or 2 points to continue as is and to give our youngsters some idea. So, sir rightly said that you should move around, see the world. So, I'm telling you about one place in India, 90 kilometers north of Ahmedabad. There is a place called Modhera Sun Temple. So, it is exactly on the Tropic of Cancer. Must visit it. So what sir was showing about the Ireland, the same thing used to happen on the equinox day when the sun used to rise. So the first ray of the sun ray went into the temple on a huge diamond, which illuminated the entire complex. So this is one thing. Then Raja Jai Singh has made 4 Jantar Mantar. Whenever you get an opportunity, anyway, you are in Delhi, so Delhi Jantar Mantar is already within your reach. Jaipur, Mathura, and Ujjain. Ujjain I had also visited. It's also very good. And then Vikrantji touched upon a very subject of my interest, astrology. So I would say some other time I will give you. Vikrantji rightly said we were very, very advanced. Whenever in the Mahabharata, Ramayana, any event, they are tied to the astronomical event. And that is how we are able to estimate the time. The birth of Ram, birth of Krishna, the event of Mahabharata, the war of Mahabharata, they are all tied to the astronomical events that were happening in sky. So because these are the events which are timeless, they keep on repeating, they can keep on repeating. And that sidereal year, yes, the Indian astronomy and Indian astrology, they follow the sidereal year. And Vikrantji, our calendar for the thousands of years has been the most accurate. Even the calendar that we are following today from the 1st January, which is called the Gregorian calendar, that error was corrected only less than 400 years back.
Okay, sir.
So because of that, when the Russian Revolution happened in 1917, 7th November 1917, Russian Revolution happened. But in Russia, it was called October Revolution. Because Russia was 10 days behind the Gregorian calendar. They did not accepted the calendar propounded by the Pope Gregory. So there were some differences. This is another story. But these are all relating to the astronomical event. Our calendar remained perfect because we followed these astronomical bodies and they are always give you the perfect idea. Thank you.
Thank you for enlightening us, sir. Okay, let's.
Thank you. Yeah. Yes, sir.
Go ahead.
Thank you so much, Arun sir. Thank you so much, Vikrant sir, for your enlightening session. We are now about to open the floor for questions. Just a small reminder to all the students, this is your final opportunity to submit your questions via the Google form, which is pinned in the comment section. All right, now we are going to start with the very first question. This question comes from Rianshi Agarwal of class 9th from Imperial Heritage School. So she's asking, why does the Northern Hemisphere experience the shortest day of the year, also known as the winter solstice, on around 21st December? So it's just a recap of that thing that you have just explained, Vikrant sir. So quickly, you can also answer this.
So as you understand, like the path the sun is taking is the shortest at this particular time of the year. If you look at the path which the sun is above your horizon, sun doesn't go very high. Like the photograph which I had shown you in the beginning, the sun is staying very low in the sky. Your shadows are very long. That means if it doesn't go very high in the sky, so if it were to go very high in the sky, it would come down also very quickly, come down also like long time after. But if it doesn't go very high, so it comes down and dips below the horizon very soon. So that is the reason we have longer nights. Can you repeat the question again? Like
So the question was, why does the Northern Hemisphere experience the shortest day of the year, also known as the winter solstice, on around 21st December?
Yeah, so why is it happening around 21st December is just a convention. Like it could have fallen on any date. I don't know whether it was particularly chosen, but one important point is that like the 21st of December, so it's like near New Year's, so New Year, but that I don't know. But the important point is that this point, year to year, thousands of years later also, this shortest night will stay the same. And the reason is, like in the presentation, I'll just quickly show that slide where this is written. So you can see why this is so. So if you were to look at this diagram, this is 21st December. I hope you can see my slide. Can you
Yes,
see?
sir.
Okay,
Yes, sir.
slide. So you can see basically this is the place where, so these are four important dates: June 21, December 21, March 19th, 23rd. So nothing is happening except that Earth is tilted. Had the Earth not been tilted, there would be none of these dates. Okay. Now what happens when these dates happen, when these tilt happens, is that there is one extreme time when the southern hemisphere is tilted most towards the sun, that is today. And on the opposite side, once the northern hemisphere is tilted most towards the sun. So these dates happen on December 21. And in like on the opposite side, it happens on June 21. So why is it the longest night? You can see in this particular video, you can see why is it long, because so this is a video by a satellite. You can see the day side also of the Earth also and night side also. So what is happening in December? So it would be somewhere here. I'll pause. So you can see this is the northern pole. This is America. You can see North America. This is the northern pole. You can see if I were to cut the Earth from here, let's take this line. So a city, this is the North Pole. Earth, like things would go around here. So any city would go around longer in the night. If a city is here, it's going to just go circle, circle, circle only in the night. So there would be no sunrise happening. So today in Arctic, there is no sunrise happening and the temperature would be minus 60 degrees. It would be the harshest cold you can imagine. So if on Uranus, on different planets, the tilt is different. So this is the reason why we have the coldest night in December 21. Or not the coldest, sorry, I missed it. So it is not the coldest time of the year still. So if there is a question, I'll answer that. It's the longest night, but not the coldest. And today is neither the earliest sunset. So if it were to be longest night, you might think that today is the earliest sunset. No, that is also not happening today. So there are many questions which can come on this. So let's take more questions.
All right, so thank you. I guess this was very specifically answered. The next question is from Space India team. This one goes from Ashish Pachori. Sir, Arun sir, I think this is more relevant to you. because he's asking how does ISRO's research contribute to our understanding of astronomical events like the winter solstice?
Okay. So our satellites basically they are launched with a specific purpose. There are many of the communication satellites, Earth imaging satellites. So all these satellites they are in a fixed orbit. They give you the image, and whatever the Vikranji has just shown, they basically corroborate whatever we theoretically we observe. So when we take an image, so naturally you can see the during the winter time you will have more part in the dark side. So our satellites they are two types I earlier told you. One is the geostationary satellite which are fixed on the 36,000 above the equator of the earth. They are mostly used for the meteorological purpose and for the communication purpose. There are other satellites which keep on spinning around the earth from pole to pole. So during this time they take images. They are mostly, for example, in the visible range. So you can see during the different time of the year. For example, now if our a satellite is moving from north to south, so it will see the duration of the image which is having the sunlit portion over India will be very less compared to when the same satellite will spin around in the June. So that gives us a clear idea about the different lengths of the day and night, and about the winter solstice and the summer solstice. So that is how our satellite helps.
All right, so thank you so much. Now, next question is from Hardik Mangla of class 8 from Ryan International School, Mayur Vihar. His question is why the day become the smallest and the longest night? Again,
Okay, so
related to the.
repeat question only. So if you were to go the same weights, you can see, like, first of all, if we are having winters, what about the, sorry, can you repeat the question just again? I think it's the same question mostly, so I'll
Yes.
just.
It's all the question goes around to the same answer as well. So
Let
he's
them
just
take an orange at home. Let them take an orange. Okay, this is the season of orange. And I don't know, अब तो वो ladies अपना वुलन अब सिलाई करती नहीं है. Our earlier generation used to do. अगर कोई पुरानी सिलाई स्वेटर बुनने की है तो उसको ऑरेंज के मिडल में से पास कर दीजिए, ठीक है. और जो उसका टॉप मोस्ट साइड है ना, उसको एक लैंप से दूर कर दीजिए. सो आपको नॉर्थ पोल पे कोई लाइट नहीं पड़ेगी. जो अभी विक्रांत जी वाज टेलिंग कि इट विल बी कंप्लीटली नाइट फॉर, आई थिंक विक्रांत जी, मोर देन अ मंथ, ऑलमोस्ट मोर देन अ मंथ और मे बी 2 months. सो वो आप एक सिंपल एक्सपेरिमेंट करके देखिए, बिकॉज सर हैज एक्सप्लेन्ड इन अ वेरी वेल वे. नाउ अनलेस यू डू इट on your own hand, then you will clearly understand what this solstice phenomena, equinoxes will be there. Vikranji, you add on that.
Yeah, so just I wanted to understand if nuances of the question. Can you repeat the question also, please?
Yes, sir. Why the day becomes the smallest and night becomes the longest?
Yeah, so basically the earth spins in 24 hours. So just subtract like the day. I'll share again the screen. So now let me take you to another screen, another slide. So you will see what is happening. It's converse. Basically, if you were to wait, let me. Share my presentation again, and from there I can show you. Yeah, can you see my presentation now?
Yes, sir, we can.
So again, the question is absolutely the same, just to show you that, of course, like you look at these sunrise, sunset times, length of the day, here is the day in Delhi, 10 hours day, and length of the night is 13 hours, 41 minutes. So if you add it, it will come to the same, okay, 24 hours. But if you also like look at St. Petersburg, there is just 5 hours long day. So the night becomes very long. So this is the extreme position. So Earth cannot go any further tilt. So the tilt is fixed, okay. So if this is no tilt, this is 23.5 degree tilt. So this tilt is fixed. So if I were to take my hand, like abhi aise hai, so this is the most I can tilt. So what is happening is like it's the tilt is not going to change. I mean, so if as the Earth is going around it, around the sun, so only like the different poles will tilt. So the extreme position when the northern hemisphere is tilted most towards the sun is June, and opposite is in winter. So yes, that is why.
And also in this chart, Vikrantji, you can focus that Saint Petersburg's latitude and Delhi's latitude. That is actually as we go higher towards the northern latitude,
Exactly.
so our days are getting shorter. Saint Petersburg's is almost 59.
Yeah, yeah. So yeah, very good point, sir. Thank you. And sir, also like that is on equator, the days are day and night are equal. Okay, so if we are experiencing longer nights here, the southern hemisphere experiencing longer days at this point of time, and equator will always be 12-hour night, 12-hour day. Very boring, no? Maybe it's good for them, but yeah, for us it would be like, okay, no seasons, not much seasons are there on equator. Okay.
All right. Thank you, sir. Especially around.
Just one small point,
Yes, sir.
taking forward what Vikrantji said. So the tilt is 23.5 degree, and suppose you subtract 23.5 degree from 90, right? Because 90 is the maximum that we take it on towards the North Pole. 0 is the equator. Delhi is 28 degree, and when we reach North Pole, let us say that is 90. So when you sub 90 minus 23.5, suppose you get 66.5 degree. Any area above 66.5 degree on today will have complete night. There will not be any day.
Exactly.
All right, thank you, sir. Now since we are actually talking about the tilt, there is one question which I also want the answer for. This is coming from Chaitanya Ahuja, who is an individual, a public question uh, from Gurugram. He is asking, how does the actual tilt of the Earth impact the occurrence and characteristics of the winter solstice? And also, what would happen in either cases if the Earth's inclination was slightly less than 20 degree or greater than that? Can
Yeah.
we call the 23.5 as an optimal tilt?
Okay, no, it would not be an optimal tilt, just that it is a good tilt. Had it been more tilt, the seasons would be more extreme. Had it been lesser tilt, the seasons will be mild. So that is the answer. As I was trying to show you, basically what is happening is, okay, like in Uranus, the tilt is 90 degrees. So imagine in Uranus, it would be always like one hemisphere is nearly 90 degrees. So it is like lying flat and rolling around the sun. So it would always be one hemisphere is always towards the sun, while the other hemisphere has complete night. So it would be winter like anything. So yeah. So what you have to understand is, I'll show you from. Wait, let me just. Where's my Zoom? Okay. Let me share my screen once again.
Sir, it's already sharing, I guess.
Yeah. Okay. So if you look at this, so why is this happening? Once again, I'll tell you some basic which I couldn't cover in the presentation. So you look at this, please. Okay. So if you look at this diagram, what is happening is, you see that if you take a torch, you can do this experiment on your own. Like there is a grid sheet and there is a torch. This is kept here and there is a circle formed by the torch light. So, and the same torch kept at the same distance from the paper, but if you make the torch inclined, the light of this torch spreads. Now, if the tilt was more, what do you think would happen to this torch? This torch would be even more inclined. So what would happen? This light would spread. So that means right now, whatever light these squares are getting, the same light, more number of squares are getting. So less light is received by each square. So if the tilt was more, this would be extreme and the light would be spread out way too much. So it would be much harsher winters. So here light can be understood as heat also.
And
All right.
and just another point. Suppose instead of 23.5 degree, our tilt is, let us say, 30 degree. Assume, just an assumption. Lesser area will be habitable, because just now, as we were discussing, above 66.5 degree, practically there is a complete night. Nobody would like to stay at a place where for months together there is a complete night. So beyond 66 degree, human habitation is much less. Of course, there will be, I think, there people may be living, there are ports and some strategic installations are there. But suppose the tilt is 30, then above 60 degree, very less human habitation will be there. So we will be like more tilt means our area of habitation will reduce on the both sides of the equator.
All right, sir. Thank you. Thank you, sir. Moving on to the next question. This one comes from the presentation that Vikrant you were showing. So this is from Karthik of Delhi Public School, Rohini. Now he is asking, what is the reason for the sun's path being in an 8-like shape that you just showed from the video?
Okay. So sun is dancing basically. So like what is a dance? Let's understand. So suppose I just move my hand up and down. That will not be a dance. But suppose I do my hands also and some my legs also and my belly also. Now it's becoming a dance. So there are two things happening. Now why is sun dancing? Because of two things. One, actually, let's say two, three things. One is sun's axis is tilted, Earth's axis is tilted, and the other, Earth's orbit is elliptical, Earth's orbit. So when Earth tries to go around its elliptical orbit, sometimes Earth slows down in it because of the gravitational pull. Sometimes it's like weaker, and some places it is more. And so basically what is happening, let me take you to that 8-shaped path. So I'm happy everyone is asking that question because that's my favorite, and we love observational astronomy. So we hope that this is okay. Let me see. Is my presentation visible now?
Visible, sir. Visible.
Okay, so just let me reach the right slide. So what is this 8-shaped path which I showed you a couple of times? Here, I'll take you to that photo rather. Let me show you this photo. So what is happening? This is a dance of the sun basically. Now, because of all these reasons, sun is not only going south and north as we discussed. So the more I bend, so suppose you are going to a temple and you bow to the deities. So I'm the earth, deity is the sun. So the more I bow, the deity is like the sun, it comes higher and higher. Okay. So here the earth is like that, and earth still towards the sun makes sometimes sun goes higher. And this is where the sun stops going higher. So this is becoming a summer solstice. And at lowest point, sun is here. So this becomes the winter solstice. So that is fine. Now you understand why is sun going up and down. So every year it traces, it will go up and down. Okay. But why is this 8? This is a complication, the dance. So this is happening because sun sometimes comes, like imagine your school bus. I'll explain in very lay person language. Imagine your school bus. You were told that your school bus will come at 7 a.m. But sometimes the driver got up early and it came at 6:45 a.m. But sometimes there was a traffic and driver came late. So why this is happening is, what is happening is near this, like at this particular time here, you can see sun is, okay, let me just imagine, this is south direction we are looking at. So left would be east. This is west. So this is where sometimes sun comes fast earlier in the sky. So sun is not perfect. Earth, because earth is not perfect. Sun is not moving anyway. We have to remember that solstice, we say that sun stands still, but sun is not moving, earth is moving, because of which this dance is happening. And sometimes just earth is moving faster in its orbit, or sometimes earth is moving slower. So sometimes that result is seen on earth. So it's like if I am in a train which is moving faster, so the faster the trees will appear to go back. Same when earth is moving a little faster in its orbit, you can just imagine, like part of the reason is that. So the sun comes earlier in the sky, and sometimes sun comes later in the sky. So this combined effect of two things is making this figure of 8 shaped called analemma. And this is what I was wanting to ask you to do it. Mark a spot on your window. Let that spot's shadow fall on a wall. Note the time, mark it. If you continue this, let's say 15 days interval, every 15 days you would have an analemma shape, and that's where after that you can always tell what date it is. So this is what the 8 shape figure is. It's called an analemma.
All right, so very well explained. Moving on to the next question. This one comes from Dev Kirti from Astronova in Bangalore, Karnataka. His question is, many people or religions believe that the solstices and equinoxes have an impact on how we as a human being function. What is your perspective and perspective of science here?
Arun sir is smiling, so let
You may proceed with the answer, sir.
Arun sir, you want to answer?
No, you carry on. No problem.
Okay, sir. So, question again. So, let me hear it properly.
The question is, many people and religions believe that the solstice and equinox have an impact on how we as a human being function. What is the perspective of science and yours as well?
Yeah, so as perspective of science is very simple. Like earlier, people did not understand it, and now we have understood it very well. Like 2000 years back, we understood Eratosthenes was the first person who gave us an insight into how the tilt of the earth functions. And it was the solstices and equinoxes are also mentioned in Mahabharata when Bhishma Pitama, like it was considered as a human species, this time is very auspicious. There were a lot of celebrations, like sun was always treated a deity. So all, you can understand today we are celebrating. What is the most special date in your life? I'm sure you would say it's your
Birthday.
birthday. And
Yeah.
today, what is the most special star in our life? Sun. It is the
And
birthday of the sun. So it has an impact because sun was seen as a deity. So the impact is like many celebrations were done this time because the sun was coming back in the sky. It was no longer saying bye bye to earth. It was saying, okay, I'm here to look after you. So the impact is like the earth, like the celebration still, like in Tamil, my friend Ranjit is there in space who was telling me that there is a celebration of Pongal happening. They like this joyous celebrations like are there for equinoxes, winter solstice, summer solstice, but this Pongal is celebrated by India in Tamil Nadu. So when they light up the lamps, so this is one significance. But Ranjit told me like his parents never told him what is astronomically happening. Now we've understood astronomically that it is the Earth's tilt and the tilted axis of it. So it's now merely a celebration, which is like a remnant of the past. It's going to continue because it has had a very profound significance. All the cultures used to, not just one culture. China celebrated it, Finland celebrated it, Scotland celebrated it. Particularly countries in the higher latitudes had more. China celebrated it. So it's like this connection is with the sun. Now people are forgetting what is the astronomical significance. For example, in India, if you ask Makar Sankranti, very few people would know that Makar Sankranti is actually Uttarayan, and very few people would be able to question even that why this is not happening on 21st of December. So true date for the Makar Sankranti should be 21st December. Like sir said a wonderful thing. So this is the implication, like so like that the same way they are the dates between Makar Sankranti and equinox are drifting. So the lesser and lesser the connection of that celebration to astronomy is happening now. So because the Hindu calendar is like a different way they measure the sun. So they like equinox is a fixed point in the sky, and solstice is a fixed point in the sky. So sun comes to, so imagine like this is a wall behind me. Imagine like, okay, you can see stars behind me. So imagine this point in the sky is called summer solstice, and sun is coming here, or let's say this is called winter solstice. This will be point when we celebrate winter solstice. And Indian culture say that, okay, we will take this particular constellation. So the thing is that this point with respect to stars and that points are drifting because Earth is having a motion. So astronomical significance is related to tilt and the motions of the Earth. So in Indian calendar, there are this, let's say there is a star, sun comes near this star. They call this as constellation. But these 2 points which are there, they are drifting apart 1 degree every 72 years. So when Indians will celebrate it next 72 years later, they would celebrate Makar Sankranti, the same festival, on
15th January.
15th of January.
Yes.
So
actually, at sometime in very past history, the entry of sun in the Makar Rashi or Capricorn also happened on 21st December. But every 70 to 76 years, it goes further. And just one point I would like to add about the human behavior. What happens during winters are very harsh at some places, even in our India on the northern side. So the grains used to be hoarded in the house because you cannot move out because of the snow and other things. So this was one of the human behaviors. I think the question he was asking. So during summer, we have plentiful of things. We can move out, get the crop, get the animal. But during winters, there was a tendency to hoard the things inside the house so that we can spend the winter. without having to move out.
All right, sir. So, since we have already talked about the astronomical significance of winter solstice, the next question comes from Samriddhi Jain of class 6 of DAV Public School. She is asking what is the astrological significance of the winter solstice. And since you are a part of astrological things, you are fond of that, I really want you to take up this question.
Okay, okay, no problem. But I will again continue what Vikrantji has told, that what happens, the our Indian calendar is built on the, it's on the sidereal concept, in the sense that every we assume the 1 year is completed when the Earth's position with respect to a fixed star come to the same position. And there is also a precision of the equinox. I will again explain what does this mean. So, for example, the Makar Sankranti is coming as of now on 14th or 15th January. So you can give a simple calculation. I am giving 365 days into what Vikranji just told, 72, 73, or 74 years. Multiply that, you will get a number which is called 26,000 years. So this, after 26,000 years, the our position of the Earth comes to the same place. So astrologically, what happens that there used to be a time when Makar Sankranti used to be on 21st December. You can see the difference of the day, 14 plus 10, 24 days into multiply by 72 or 73 years. You will find that in the past. So the reason the astrological phenomena used to have a very important role is that our ancient people, they did not have the instruments which we have today. What Vikranji has shown, so many instruments where we can prove that the movement of Earth with respect to the sun and other planets are so much precise. So they relied on the fixed constellation in the sky, whatever they can view. With reference to that, they assume now, because the sun is entering the Makar Rashi in our Hindi terms, or in the Capricorn constellation, they used to say now this is the 14th January, and accordingly all the religious significance, what Vikranji mentioned about the Kumbh Mela that used to happen, because the way they used to view the sky was without any instrument. It was only the observational thing was there. Now we have so many instruments, we have satellites in the space, so we can see far away actual tilt of the Earth, the movement of the Earth. So that was the reason. I hope she understand, but I will, some later date I will give more explanation on
No,
this.
no, sir.
All right, sir. Clear. All clear, I guess. Okay, so this question comes from Ansh Chaudhary of Bal Bharati Public School, Gangaram branch. His question is, as the Earth revolution is 365 days and 6 hours, then being a leap year, why the solstice doesn't change?
Okay, so actually it changes by that amount of time. So for example, it was 2:51 p.m. today. If you were to check next year, it would come 6 hours later. If you were to come next year, it would come 6 hours later. Next year, 6 hours later. Next year, 6 hours later. And then fourth year, it will reset, because we'll add an extra leap year. So the date would again come back. So this calendar, which we are talking about, Gregorian calendar we are using, it's a very advanced and sophisticated calendar. So his question is very wonderful. Actually, leap year does happen. So only thing is, like today, we've just talked about one date. I don't have the other dates for the other years, but actually it happens six hours later, and the fourth year it resets to the same place. So this equinox is always going to happen either on December 21 or 22 for a long time. So yes, and our one thing which I wanted to mention, like I mentioned earlier. So what is a year? What do you think is a year? You think that the year 365 days and 6 hours at that is actually the Earth's orbit getting completed. But what I was mind blown today while in the night is like, actually, it is 20 minutes less than relation to the stars. So we thought that Earth's orbit will complete a circle. Now that circle should always be, like in my mind, it always hits like it should be with respect to the stars. But the calendar we are following in 15,000 years from now, when you say 15,000 years now, so Earth would have taken half a revolution extra. So maybe I just added a little extra to this question. So leap year is in consideration. Totally.
All right, sir. Thank you.
Very
Okay.
sophisticated calculations have happened. So to do this, to make like you think it's 1 year, very simple. But when you go into everything, like the way Hindu calendar is, there's so many corrections are added to it to make everything running smoothly for all of us.
All right, sir. Thank you. Now, moving on to the next question. This one comes from a student of Prudence School, Dwarka 16B. Now, his question is: does the concept of solstice exist in societies which develop near the equator, since they would not have noticed the tilt of the earth much?
So, yeah. So naturally, we haven't seen it develop near equator. Like as I was sharing, like there were many folklores which were there from the countries which are away from the equator, but not on the equator. Surprisingly, it's there celebrated in India, also in Tamil Nadu, which is closer to the equator than anyone can imagine. And there is a big celebration. So as far as we know, like just 10 degrees above the equator, this celebration is there. And in northern you go, but exactly at equator, I doubt, and I haven't come across anything. But
No,
then
I agree. I agree because they would not have observed in the for a long time. They would not observe any change. 12 hours day, 12 hours night.
All right. Arun sir, this one goes for you. This question is for Adrika. She is from KIIT Bhubaneswar. Now, the question is: how does Project Paridhi focuses on the winter solstice contribute to our understanding of ancient timekeeping systems, and have any surprising cultural or scientific insights emerged from it? Do you want me to repeat it once more?
No, no, it's okay. So
All right, sir.
basically, again, I think they want to connect it to our the way we used to have our calendar. So as you also mentioned now, because we have sophisticated instruments which can measure up to the micro level, microsecond level. So our ancient culture did not have all these instruments. They used to observe the sky through simply their naked eye, and I do not have any record what observation they kept. But whatever I had studied on my own as a hobby in terms of the astrology, I found that they were they were quite accurate. Of course, the difference between the whatever the tropical year of the 21st December and the sidereal year of the Makar Sankranti that we have, that difference doesn't impact the overall concept. Both agree that there is a tilt of Earth. There is no difference of opinion on these two thoughts process that Earth tilt is not there. The only difference comes because the our ancient I would use the word rishis, because all these our sages had developed this. The term scientist does not exist in those times of year where I'm talking 5,000, 10,000 years back. So they simply observed, and their observation always tend to see these 12 rashis. In astrology we say 12 rashis, or you can say the 12 zodiac signs, which we call, starting from Aries and ending at Pisces. So they used to observe the when the sun is entering one of these zodiac signs, and accordingly they used to define. For example, let us say the mid of the April, we say there is a season called Baisakhi in the northern India around 13th April. So at that time, Sun is entering the Aries zodiac sign as per the sidereal system. Of course, there is a difference with the Western astronomy, Western astrology. It happens around mid of the March. So that difference doesn't, again, I would say, doesn't make any conflict about the basic scientific temperament that, of course, there is a tilt that causes the season. So we both are on the same thing, except like you can say there is some delta or some difference in the numbers.
All right, sir. Thank you so much. Now, since we are going to have one or two questions more only, so could you please just briefly explain to the students, since there are a lot of comments, what is equinox, what is winter solstice, why do we call it solstice only? There are a lot of questions, and I can see that. So if you can just briefly describe them, and then I'll ask one more question, and that would be the wrap.
Now,
Okay.
Vikranji is the best person because
Okay. Sol. Okay. Sol in Latin means sun. Stis means to stop. Once again, I'll repeat. Sun is not moving. Okay. In like the larger universe, sun is only moving around our galaxy. But when like a train is moving and you are inside it, you see that the trees are moving. So solstice means the extreme points. So sun is traveling in our sky apparently as Earth goes around it. So sun moves northwards and southwards in the sky. So suppose I have this south horizon, and today is winter. So what is exactly solstice? I'll just, so sun would rise, okay, in this direction it will go here if I'm in New Delhi or in India. But in summers it goes like this, higher. That means if you look at noon time every day, sun would be here, 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 here. In June, it will be at its highest point. It will stop. Ruk gaya, sun is stopped. And then it's going down, 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 down. So this is solstice. Two solstices. One is the summer, one is winter. Now, when we say summer, it is winter for southern hemisphere. And when we say in northern hemisphere, it is winter solstice. At the same time, it is winters in the southern hemisphere. This is solstice. Equinox is the midpoint between these two when the nights are equal to day. So in solstices, in like wherever you are having summer solstice, it will be longest day. Okay, but in winter solstice it will be the shortest day. Somewhere in between is the equinox, when the Earth's tilt. Earth is not tilted with respect to the sun. Earth's axis is tilted, but with respect to the sun, it is not tilted. So this is a bottle. Right now it is tilted with respect to the camera. Right now it is tilted with respect to the camera, but right now it is tilted, like for the camera it is not tilted, towards or away it is not tilted. So when this happens, when the Earth's axis is not tilted with respect to the sun, imagine in this case the sun was this, so it would be called equinox. Nox means night, equi means equal, and there are these are four important dates in our year. So like equinoxes happen in spring, in March 21. That is called the spring equinox for us in northern hemisphere, and it is called autumnal equinox when it happens in September. So I can show you the diagram what is exactly this equinox is. So let's go here. So basically these two times are the equinoxes. This is the Earth's orbit around the sun, and this is solstice time. This time of the year when Earth's axis is only sideways tilted but not towards or away from the sun, this is called the equinox. So the theoretically during equinox, if there was no atmosphere on the Earth, then only and even then not, because sun is a bigger thing. So imagine, okay, to keep it very simple, I would say that let's remove the atmosphere from the Earth. So if when the Earth is near 19th or 20th March and September 23rd, it would experience equal sun and equal night. But there are more complications to it. The day would be a little longer than the night in real sense.
And Vikrantji, can I add one point?
Please.
Sure, sir.
On equinoxes, sun is exactly overhead equator. Today, sun is exactly on the over the Tropic of Capricorn, and on summer solstice, sun is exactly over the Tropic of Cancer.
Exactly. Thank you so much.
Exactly, sir.
That's a very important point sir has added. So yeah, so sun comes over different latitudes of Earth. Here you can see in winter solstice day it is overhead this particular latitude of Earth. Here it is overhead this particular. These are very special latitudes. One is called Capricorn, Tropic of this is Tropic of Cancer. One is called Tropic of Capricorn. So if you were to live in between these two latitudes, you would see sun come overhead you. Okay, it would like on these particular dates. Only these two dates, yeah.
All right, sir. Thank you so.
Great questions, and everything got clarified, I hope.
Yeah.
So many questions came. That is such a wonderful thing.
Sir, Arun sir, I guess this question would be the last one, and this question directly goes to you because they are asking for what advice would you give to young students interested in studying astronomy and even working later on for ISRO and submissions?
So for studying astronomy, you do your science subjects in your class 12th, and you can take up, for example, physics as a undergraduate course in your Bachelor of Science, and can further pursue MSc Masters in physics. Then India has many renowned institutes working in astronomy in every part of India. Pune, there is Ayuka, NCRA, Nainital, Bhubaneswar. Bangalore has many good institutions. So they further research studies, they can do it there. They can do their doctorate, PhD. And for ISRO, you need not be restricted to only science. ISRO needs from every discipline. So we need a computer scientist, mechanical engineer, electrical engineer, physicist, agriculture scientist. So it's completely open they for the development of our systems. And also once the satellite is in place, a lot of data from the space comes observing the Earth. So the data analytics is another important field where the specialist scientists are required. For example, now our satellite images from November onwards till March, they give us the images of the northern India where wheat is sown. So it is regularly updated to the farmers how the wheat is growing, and also an estimate is also made based upon which the crucial decisions are taken, whether to allow the export, whether to we require the import. So every type of anything, even statistics, mathematics, all these fields for ISRO they are open. Particularly for astronomy, I told physics is one of the important subject which you need to study.
Thank you, sir. Thank you so
All,
much. Enlightening.
all right, sir. Thank you once again, Dr. Arun Bhardwaj and Mr. Vikrant Narang, for sharing your expertise with us. Your contribution to science and space exploration are truly inspirational. And to all the participants, we were actually flooded with a lot of questions. I hope we have done justice to your questions and we have answered it, most of it.
I am getting a message from one of our known. They say he's a class 2 student. His question is not asked. I said I will answer separately.
We have a lot of questions, and that's not possible to answer most of the questions. But yeah, majorly we have answered everything, I
Let
guess.
sir answer it then if he has sent a question.
Yeah. They are sending, so that kid will be happy, and we can hope that he also
Sure.
comes into science. Let me get the question, because these our kids are to be inspired.
Exactly, sir.
Exactly.
Oh, so the question is again the last question which just now Rishitaji has asked. I am in class 2 and how I can become an ISRO scientist. So,
Yeah.
so I already answered, and he's also asking how far we have gone in space till now. So the farthest one is our International Space Station, 300 kilometers above the Earth's surface, and the farthest we have human has gone up to the moon. That is 3 lakh 84,000 kilometers away from. This is what the human have gone so far. So maybe let us hope all these our young budding scientists do much more technological innovations and we can reach up to the Mars. Thank you. And
Thank you so much, sir.
let me thank to particularly Space India, very much to Vikrant ji, Rishita ji, and because the names I know very limited, Diksha ji and Pooja Tiwari ma'am, who called me and gave me all the details. So I am really thankful. And many names I have not taken, but that doesn't mean I am not appreciative of that, of all the Space India team. Thank you.
Thank you,
Yeah,
sir. Thank you.
Thank you so much, sir. We are honored with your presence, and I would like to thank Space Team, also all the people who are working behind the scenes to make this, and our students. Thank you for all the wonderful questions you have asked today.
Exactly.
Happy Winter Solstice to all.
Thank you.
So, to all our participants, thank you for being a part of this remarkable event. Remember, the journey to uncover the universe's secrets begin with curiosity. Keep exploring, keep observing, and we'll see you at the next Space India event. Have a great day. Meanwhile, if you want to get updated on these kind of more events, you can follow us on our social media channels. Thank you so much, everyone. Have a great day ahead and happy winter solstice.
And coming Happy New Year to all. Thank you.
All exactly, sir.
Thank you. Bye.
Bye.